tanker damage stability. Paul Coley and Nick Quamby. Maritime and the Coast Guard Agency. Background. The UK first became concerned over the issue of damage stability verification on tank vessels in 2005 as a result of problems highlighted during flag-in of tank vessels, port state control inspection and a survey of UK tank ship operators. Issues identified at flag-in: low or zero margins on stability in worst case of damage. Damage cases missing from the damage stability evaluation, particularly lesser cases. Insufficient consideration given to slack or partially filled tanks. Insufficient consideration given to use of deck tanks. Approvals based upon unrealistic conditions of loading. Of 11 LPG and chemical tanker stability approvals considered for endorsement by the UK at this time, 7 were found to be incorrectly based and to omit critical elements to the verification. This is a rejection rate of 63%. Port state control observations. Vessels loading alternate conditions from those in the approved stability book. Vessels appraising loading conditions using longitudinal strength computer with additional intact stability assessment. Masters endorsing loading conditions clearly marked not valid for damage. Survey of UK tanker operators. How many vessels operated, including foreign flag vessels in their fleets? Do they load alternate conditions from the SIB? Do they operate with empty or slack tanks? Do they verify stability prior to departure? Do they verify using intact or damage stability assessment? Survey results: total of 76 ships operated. 59 vessels, 77%, load alternate conditions. 43 vessels, 56%, regularly operate with slack or empty tanks. 69 vessels, 90%, are fitted with stability assessment programs. 30 vessels, 39%, only assess intact stability. Conclusions. Insufficient pre-departure checks are being made on tank vessels to ensure compliance with statutory damage stability requirements. Existing stability approvals for these vessels may not always ensure that these requirements are met. There is a compelling need for enforcement action to be undertaken to ensure that existing international instruments are being complied with. Recent flag-in cases for various tanker types have revealed that stability approvals for such vessels commonly exhibit no margin on stability for the sample intact loading conditions included in the Stability Information Book. When sample loading conditions are subsequently obtained, it is common to find that these do not meet basic damage stability, as the optimized intact GMF used in the initial approval cannot be sustained in practice. UK response. To publicise the issue amongst UK operators, IACS and International Tanker Operators Associations. To consult other flag states on the issue and to consider proposals for coordinated enforcement of existing international instruments. With others, to draw attention of this issue to EMO through MSC 83/25/14, proposing development of a common interpretation for these instruments to enable consistent enforcement action to be taken. To propose that guidelines be developed for tank ship stability approval in the expectation these will be taken up by IACS under the umbrella of URL 5. IACS Unified Requirement URL 5. IACS has introduced a new requirement relating to stability computation under URL 5. This makes it mandatory for loading computers fitted to any IACS class vessel contracted after the 1st of July 2005, which incorporate a stability element, to be approved to verify all aspects of stability which apply to the vessel, including damage requirements. This entire issue has been recognized by IACS in their introduction of a new Unified Requirement URL 5 for load line, which provides that any loading computer incorporating a stability element fitted in an IACS-class vessel contracted after the 1st of July 2005 should be capable of executing all stability verifications which apply to the class of vessel under consideration. The introduction of this URL leaves us with a need to address procedures on the existing vessels not covered by its provisions. Enforcement. Guidelines for a common interpretation of the international instruments are necessary to ensure consistent enforcement action. However, the need for enforcement action is clear and is not dependent upon such guidelines being developed. As a flag and port state administration, the UK will seek to pursue coordinated enforcement action if guidelines cannot be agreed within an acceptable timescale. Enforcement. Enforcement action shall apply only to those vessels which do not operate according to their existing stability approval. Vessels which adhere closely to their approved loading conditions will not be required to provide direct means of verification. A definition of what constitutes closely loaded is required to verify loading is in accordance with the approved conditions. Enforcement. Where alternate conditions of loading are employed, verification by means of critical kg or gm data is acceptable subject to any parameters fixed to determine the critical data being verified as met. It is the opinion of the UK that such verifications should be made using a URL 5 Type 2 stability program to provide an auditable record for PC inspection. Enforcement. It is the opinion of the UK and its co-sponsors that where vessels load alternate conditions significantly different from those in the approved stability book, these should be verified on board using a URL 5 Type 3 stability program. Enforcement, proposal. Inspection campaign to identify where vessels are loading to alternate conditions without acceptable damage verification. In such cases, an operational ISM defect to be raised against the ship and letter of warning to be issued. Should further cases of loading alternate conditions become apparent at subsequent inspections, detention or banning to be considered. Enforcement, conclusion. During any forthcoming inspection and enforcement campaign, operators must ensure that crews can produce records on board to demonstrate that damage stability has been verified. UK strongly recommends the provision of damage stability programs for this purpose on any existing vessel where adherence to the approved conditions is not practicable. All operators should be aware that in any forthcoming inspection campaign their vessels will be required to produce records which demonstrate that damage stability has been verified. In this respect, operators should take full advantage to appraise their systems prior to the commencement of any enforcement campaign. Operational considerations. Basic pre-departure checks. Longitudinal strength, load line. Intact stability, load line. Damage stability. Oil tankers, MARPOL Annex 1, Reg 25. Gas tankers, IGC Code, Chapter 2. Chemical tankers, IBC Code, Chapter 2. In order to operate safely, and within statutory requirements, the following checks require to be made prior to departure. Strength is a class requirement on all vessels exceeding 65 meters length. Intact stability is normally assessed using an intact stability function attached to the basic loading computer program used to assess strength, but damage assessment is commonly omitted. There is a common presumption that intact stability assessment against a critical intact GMF curve is sufficient, but it is not. Documentation on board. Approved stability information. Intact loading conditions. Damage calculations. Certification. Oil tankers, IOPP certificate and Form B. Gas tankers, certificate of fitness. Chemical tankers, certificate of fitness. Statutory documentation held on board will include the approved intact stability information, which will typically make no reference to damage stability requirements. A set of damage calculations, which verify only that the sample intact loading conditions in the approved intact stability information comply with damage, and typically with no reserve margin on the worst case, and the statutory certification applicable to the type of tank ship concerned. IOPP Form B 5.7 Subdivision and Stability, Regulation 25. 5.7.1 The ship is required to be constructed according to, and complies with, the requirements of Regulation 25. 5.7.2 Information and data required under Regulation 25(5) have been supplied to the ship in an approved form. It may be noted that the basic requirement in the case of MARPOL Annex 1 certification is for the vessel to comply with Reg 25(5), and that this requires information to be provided to the master in an approved form such that the stability of the vessel may readily be established in any condition of loading. It would be the view of MCA, as the UK Maritime Administration, that this requires the stability information to be sufficiently detailed in scope to enable the loading officer to assess whether minor loading variations from the sample intact loading conditions in the approved intact stability information remain compliant with damage, or should be prohibited. As a minimum there should be information relating to empty or slack tanks, use of deck tanks where fitted, and the use of ballast. A lack of such detailed data renders the vessel unable to load minor variations from the standard loading conditions without referring these to flag or class for prior approval, and this therefore limits the practical operation of the vessel. IGC and IBC certificates of fitness. 5. That the ship must be loaded. Point 1. In accordance with the loading conditions provided in the approved loading manual, stamped and dated, and signed by a responsible officer of the administration, or of an organization recognized by the administration, or Point 2. In accordance with the loading limitations appended to this certificate. Where it is required to load the ship other than in accordance with the above instruction, then the necessary calculations to justify the proposed loading conditions should be communicated to the certifying administration, who may authorize in writing the adoption of the proposed loading condition. The warning statement included on the certificate of fitness for IBC and IGC vessels is more stark. It clarifies the position previously given for the MARPOL vessels, by including a direct reference to the need for flag or class approval of alternate loading conditions on the certificate. For MARPOL vessels, this warning is normally included in the intact stability information and on the approval documents normally issued by class. Masters and owners' responsibilities. International Safety Management, ISM. Paragraph 1.2.3.1, the company should establish a safety and environmental policy which ensures compliance with mandatory rules and regulations. Paragraph 7, the company should establish procedures for the preparation of plans and instructions, including checklists as appropriate, for key shipboard operations concerning the safety of the ship and the prevention of pollution. The various tasks involved should be defined and assigned to qualified personnel. Under ISM provisions, it is incumbent upon companies to put procedures in place, including checklists if appropriate, to ensure that statutory requirements are met. This provision clearly extends to verification of stability compliance, including damage compliance, prior to departure from port. It is clear from inspection of UK and foreign tank vessels that company safety management systems rarely formalize this requirement, and that it is common to find intact loading conditions signed off by the master which carry warnings such as this loading condition complies with intact stability only, damage stability to be verified also, or similar. Stability considerations. To consider the factors which may influence consideration of variations in loading. Typical stability approval at build. Intact stability information booklet. Contains sample intact loading conditions. On approval, these intact loading conditions are themselves deemed to be approved for use. Damage stability appraisal. Usually a separate submission. Demonstrates only that the approved intact loading conditions will survive the extent of damage required by the applicable convention or code, and achieve the minimum residual stability standard. As previously discussed, the stability approval at build typically comprises production of an intact stability information booklet which includes sample intact loading conditions, which may be selectively derived, which show compliance with damage stability requirements in a separate document. Once formal approval is issued, then the sample loading conditions themselves become approved for use in loading the vessel, but variations in loading, or alternate loading conditions, are specifically excluded from the approval. If the approved intact stability information does not contain any cohesive information on how the loading may be varied safely from the approved loading conditions, then the operability of the vessel is necessarily restricted to these loading conditions alone. In this approach, damage is applied directly to the approved loading conditions on a case-by-case basis. The results, and the approval, is therefore conditional upon the assumption that the following parameters remain unchanged in the loaded vessel, otherwise damage results may be adversely affected. Cargo SG, draft and or trim, empty/part filled cargo tanks, cargo or ballast distribution, use of deck tanks. In restricting the loading to the approved conditions, there is no scope for even minor variation in loading unless the effects of such variation on damage stability compliance can be assessed. In this sense, any variation in cargo SG, draft or trim, loading of partially filled or empty tanks, changes to the approved cargo or ballast distribution, or the use of deck tanks may make an approved condition non-compliant if guidance is not provided to assess the effects on residual stability after damage. Variation in loading. The ability to load a vessel is restricted where approval is granted on the basis of damage appraisal of approved intact loading conditions. This may be of little consequence on a large deep-sea vessel fulfilling a long-term charter, but it is likely to prove problematic for a small coastal parcel tanker. It is often considered that alternate loading conditions are acceptable, particularly where these do not deviate significantly from the approved intact loading conditions, but there is no safe basis for this conclusion. Restricting variation in loading becomes more important as the margin on residual stability calculated in the damage appraisal decreases. In vessels with no margin on stability, there is no scope to vary loading, and the commonly accepted concept that the vessel may be loaded closely to or not significantly different from an approved loading condition may be erroneous. Significant variation. It is the opinion of the UK and its co-sponsors that the concept of a significant deviation from an approved loading condition requires to be defined. We are presently proposing that a loading condition should be considered to deviate significantly from an approved condition if the following limits are exceeded. Contents of cargo and ballast tanks, 1% by weight. Overall condition kg or gm, corrected for Fs, ±2 cm. Scope to vary loading therefore depends upon the margin within which such a variation can be accommodated, and the quality of the information supplied to the master to permit such a variation to be effectively evaluated. Critical kg data. It is possible to derive critical kg data which satisfy statutory residual stability criteria, but this is normally calculated only on those classes of vessel where the damaged compartments are considered to be empty, or loaded with a fixed permeability. Whilst it is theoretically possible to derive such data for a tank ship, this would have to be conditional upon many initial assumptions, regarding filling level, initial draft trim and GMF, cargo SG, filling of the adjacent tanks and the damage location, each of which would have to be replicated in a live loading condition before such limiting data could be applied. Looking at a typical passenger ship. Vessel heels toward the statutory damage case, all damaged tanks are flooded, and the critical intact GMF leading to exact compliance with the residual criteria can be readily determined. Where a vessel cannot comply with statutory damage, then pre-filling tanks, as indicated, gives scope to reduce the overall effect of damage and to reduce the critical GMF value. However, it may be noted that application of this principle on a tank vessel will only serve to reduce cargo carrying capacity, or to reduce operational flexibility. Typical tanker cross-section. Consider a basic tank ship cross-section, loaded with low SG cargo. Suppose the vessel is loaded with a low SG cargo. What is the likely effect of damage? Heels toward damage. In this case, the mass of floodwater is likely to exceed that of the lost cargo, and the vessel may heel toward the damage, loaded with high SG cargo. Considering the same vessel with a high SG cargo, heels away from damage. The lost cargo mass now exceeds the weight of floodwater, so the heel is away from the damage vessel at deep draft. Considering the effects of initial draft, or local trim, on damage outcome for a deep condition. Heels toward damage. Tendency shall be for the vessel to heel toward the damage for lower SG cargoes, as flooded mass will not exceed lost cargo mass, vessel at light draft. However, for light draft conditions and a wider range of SGs, the opposite effect will tend to occur. Heels away from damage. Retained cargo mass exceeds mass of floodwater following damage. Full tanks. Similar effects will be noted through variation of cargo filling. For example, a vessel with full tanks, heels away after damage, will tend to heel toward the damage as lost cargo mass is maximized and may only be partially replaced by seawater. Slack tanks. When we consider the same damage case with partially full, slack tanks, the opposite effect will tend to occur, heels toward damage. Floodwater mass will tend to exceed mass of lost cargo. Empty tanks. The most extreme effect shall be on empty tanks, particularly in combination with empty ballast tanks outboard. Severe heel toward damage. With unrestricted flooding and no compensating loss of initial cargo mass, resultant heels are likely to be extreme. Typical tanker layout. If we consider a typical tank layout for a small coastal tanker. Typical single SG loading pattern. For a typical single SG loading pattern from the loading manual, a critical damage case will be determined in the damage stability assessment. Typical alternate SG loading pattern. However, for a differing single SG cargo, the critical damage case may change, particularly where cargo distribution is varied between loading conditions to meet damage requirements. It is also evident that the loading manual does not give adequate guidance on the carriage of single SG cargoes between the two cargo SGs if the cargo distribution does not vary progressively. Significant variation. When one considers the possibility of the need to vary cargo distributions, and mixed SG cargoes in particular, then typical loading manuals do not consider this issue in any depth. Ultimately, it may not be known where the critical damage lies or whether the condition meets damage stability requirements. Significant variation. An additional consideration is in the use of deck tanks. Again, use of these tanks are typically not covered in any depth or examined for damage stability compliance, so worst damage case may not be known, nor whether residual stability standards will be met. Typical condition. When one moves to a typical parcel loading condition for a coastal tanker, the lack of detail in a conventional approved loading manual becomes apparent. Consider variation in cargo SG. Variation in cargo SG is of particular relevance when considering alternate conditions of loading, as apparently minor variations from approved loading conditions can render these non-compliant with damage stability requirements. For any loading condition, the local cargo tank VCG contributes to the global VCG for the vessel. Cargo and condition kg both rise. However, carrying the same mass of a lower VCG cargo will raise the local cargo VCG, and hence, the global VCG of the condition. This may then render the condition non-compliant. The sensitivity of approved cargo loading conditions to minor variations in cargo SG can be demonstrated if one considers a residual stability curve, indicated green, that meets the minimum requirement for residual GZ of 100 mm. If the peak occurs at 40 degrees, then an increase in initial condition VCG of only 155 mm will totally eliminate the residual curve. This example of a damage stability appraisal for a coastal tanker shows the typical scale of peak residual GZ values for each loading condition in the final column. If we consider the approved loading condition for the worst case of damage, it will be seen that the tank fillings vary between port and starboard by a significant amount, but that this was not reflected in the damage cases run. Vessel is not at its marks at SG 0.63 or SG 0.74. This is another example of typical margins on stability for approved loading conditions from a chemical tanker. It may be noted that the margins are low in several instances and that this limited compliance can be compromised by filling of deck tanks, not considered for SGs 0.74 or 1.9, or by minor reduction in cargo SG, in the case of the 1.9 SG cargo, or by the addition of extra cargo to bring the vessel to the marks, in the case of the 0.63 and 0.74 SG cargoes. Vessel is not at its marks at SG 0.63 or SG 0.74.